and welcome to another session where I am going to tackle another important problem in dynamic programming. This is also a very popular Google interview question. This is the Leetcode number 361 titled Bomb Enemy. So the question says that you have a 2D grid where there are three symbols in that grid. So capital W means wall, capital E means enemy, and 0 means empty. So we have to return the maximum number of enemies which we can kill using just one bomb. There are two conditions. We can place bomb only at the empty cell. So basically bomb can be placed only in places where there are zeros. And second is bomb is powerful enough to kill all enemies in the same row and column. So for example, if the bomb is placed here in first row third column, so all enemies in the first row and third column will be killed. But there is another condition that the walls are very powerful, very strong, and the walls are not affected by bomb. So unless a wall come in the way, all enemies will die from that bomb. So basically we have to count the number of enemies tackle. So the two conditions, the walls are never destroyed and the bombs, there is just one bomb to be placed at one of the empty space. So we have to find what is the maximum number of enemies which can be killed, and we don't have to find the place where we can place the bomb, but we can find the index as well on the grid. So let's say we have an input here with 3 rows and 4 columns. Here we see we have 0 E 0 0, then E 0 W E 0 E 0 0. 0 means empty cell, E means enemy, and W means wall. Let's try to think of a grid grid buffer. So grid is our input, but we defined a grid buffer. This is a temporary variable of the same size as the input grid. And let's say for every point we will write the number of enemies which can be killed by placing the bomb at that place. So first of all, we know that we cannot place a bomb at place where there is an enemy E or W. So all the indexes with E or W will be 0. So here you see we keep 0 to all the W and E. Now for all the zeros in the original grid, we can put a bomb. So let's say I put a bomb here in the first row, first column, and now there is one enemy in the column, one in the row. So total can be destroyed is 2. Similarly, if I keep here, I have just 1 in the row and nothing in column because there is a wall. So it's 1. And if I keep a bomb here, 1 in the row and 1 in the column becomes 2. Similarly, if I keep here the 2 in the column and 1 in the row, because this will be destroyed but not after wall because wall is strong enough. So there's 2 in the column, 1 in the row, 3, and then we have 0 here in the third row and first column. And for this number we have 1 in the column and 1 in the row, number 2. And then here for this element we have nothing in the column because there is a wall, and we have just 1 in the row, so we have 1. And for the last element we have 1 in the column and 1 in the row, so we have 2. So now this grid buffer is our main goal. We have to program or algorithmically find the grid buffer, and from this grid buffer we will be able to find the maximum number of bombs. So maximum number of bombs is the maximum of the all elements in this grid buffer, which is clearly the 3. And we can also find the indices of this variable. So if we keep in the second row, second column, we can find the spot which has the maximum number of enemy which can be died. So I'm just going to discuss not a brute force solution, just optimized solution for m n, where mn are the dimensions of the grid buffer, and n space complexity. So this is what we have. Well, space complexity is not that critical, so I think it will be OMN as well, space complexity, because we are storing the grid buffer. But here the OMN time is optimized, so we just have two nested loops. We will get this grid buffer matrix by a two-way operation traversal. So we will go through the grid starting from the first row from left to right, then second row left to right, then the third row left to right, and again we will make two loops to traverse the grid, now in the reverse order. So the last row right to left starting from here, then the second row right to left, and then the first row right to left. Okay, so two times we will traverse, and for traversing through the grid we need a two for loops. That's why the complexity becomes OM into n. Okay, so now I hope this example and the grid buffer make your concepts clear. Now it's not clear how we can compute it algorithmically, so I will explain it with the help of an example, this same example on the third page. So and then we will come back to program. Okay, so let's go back to the third page where I have a nice example. So the third page we have this example. So grid, we have the same example as I had in the first page, and here we have n representing the number of rows, so n is equals to 3 rows, and small m represents the number of columns, which is 4. 1 2 3 4 columns. So we initialize the grid buffer to 0 0 0 0, all values 0, and we know that the grid buffer will have non-zero only at those places where we can keep the bomb, or at those places where we have 0 in initial grid. So basically this place, this place, this place, we will be updating them to some non-zero values, and we know that rest of the values will be 0 for sure. So as I told you, we will traverse the grid two times, first from left to right, top to bottom, and then in the reverse order, bottom to up, right to left. So let's go through the stage 1. So in stage 1 we have two variables. I is the row variable which changes from 0 1 2, so we first traverse the first row, second row, and then the third row. And j is the column variable which changes from 0 1 2 3, so first column, second column, three column, four column. So basically from left to right, top to bottom, stage 1. In this process, so here I'm writing that loop thing. So first loop is for I, which is row, and second loop is for column. So column, for each row we run this algorithm for all the columns. So here we have a variable known as left tb, left tab. So left tab is initialized to 0. You will see what does it mean later. And then we define a call buff. Call buff is initialized a column, is a 4-dimensional array, 0 0 0 0 column buffer, and it is supposed to store some values for each column. So it tracks the dynamics. Here for each row we run this for each I and j. So I will just talk about inner loop because outer loop is handled by itself. So whenever we change a row, like for outer loop, we have to reset the value of left tab is equals to 0. So basically left tab counts the number of enemies to the left of the index, and that is why whenever we change the row we have to initialize to 0, because for each row initially we have nothing to the right, nothing to the left, because we are starting from the left. And the column buffer is initialized to 0 0 0 0 in the beginning out of both of the loops. But when we go from one row to the next row, the column buffer has memory, it retains its value. There is no reset because it is representing the column statistics. It is representing the number of enemies which can be killed by placing bomb at I comma j grid in that column, and it's not affected by rows, so it remains the same. So what we do, we have, so for every grid I comma j, here we have three choices. It can be 0, it can be e, it can be w, and depending on these three values we will doing some operation. So let's say I got an E, which is enemy. So if any grid I comma j, any element becomes enemy, what I will do? I will increase the value of left tab is equals to 1. So left tab is temporary variable, it is increased by 1, and the column buffer, that column j, so call buffer j is also increased by 1. So if I found an enemy here, basically column buffer corresponding to the first component becomes 1, from 0 to 1. So tab and corresponding column buffer increased by 1 if we found an enemy. However, if we found a wall, both the left tab becomes 0 and column buffer becomes 0. You can understand it why, because the wall is immune to the bomb, and so it will clear any effect of the bomb on the left side, on the other side of after it. So that's why it has to be 0, and the column buffer also becomes 0 because bomb is also the wall is also immune towards both rows and column wise. And the third is the most interesting. If we found 0, it means we can place a bomb here. So we update the grid buffer by adding 2 elements to the grid buffer. Left tab means number of left enemies plus column buffer plus number of enemies which are available in the column. Okay, and we keep doing it. So let's go keep this algorithm in mind and iterate through all the 3 rows of the grid buffer. So I will keep writing I is equals to 0 to represent the first row, and I is equals to 1 for second, I is equals to 2 for the third and last row. So in the first row, it's very clear that we will update only the values of first row of grid buffer. So we start with left tab is equals to 0, column buffer is equal to 0, 0, 0, 0. So column buffer is all 0. Okay, I just write call buffer is equal to 0, but instead actually this is 0, 0, 0, 0, 4 times 0. So what we found, and we will look into the grid values, not grid buffer, and we will update grid buffer by looking at the grid values. So we see 0, 0. So when we have 0, 0, what we know, we add left tab and column buffer to the grid value. So grid value was 0, left tab and column buffer is both 0, so it stays the 0. For E, we do nothing. So grid buffer is not updated for E or W, so it remains the same 0. Then again we got 1 here or 0 here, and now we have to update the O. So as we said, when we get the enemy, we increase the value of left tab on column J, call buffer J. So call buffer J becomes 1 now. So it becomes 1. We update here 1, and we are right now here. So we update it to 1, and we update left tab to 1, and we put here 0 because nothing is updated. Grid buffer is not updated. When we move to this position, the third position, the first row, we have 0, and now we have to update the grid buffer. So grid buffer initial value is 0. We add the left tab value to it. So left tab is 1, and call buffer G is equals to 0 because we have the call buffer just updated for the first 2 conditions, and it was initialized to 0. Still it is 0, so it becomes 1 plus 0 plus 0 becomes 1. Then the fourth one, again we have is initial value 0 for grid buffer, left tab is still 1, so we add the left tab, and the column buffer is 0, so we add that and becomes 1. So we got the first row of the grid buffer updated to 0, 0, 1, 1 after the first iteration of first row, and the column buffer now is 0, 1, 0, 0. Now remember, when we are going to second column, we will look into the values in second row of the grid. So when we are going to second row of the grid, we will look into this value. Now we will go ahead and reset the left tab. So left tab becomes again 0 because we are starting again from left, but column buffer will remain the same. So now we will, instead from all 0 column buffer, we will start from 0, 1, 0, 0. So let's say we have a E enemy, so left buffer becomes 1 and column corresponding to 1 becomes 1. So at this point we update this column buffer to 1, and enemy will correspond to 0. So now the 0, 0, 1, 1 is copied already. Now we are just updating second row, so 0 stays the same because this is enemy, but because of enemy the left tab becomes 1 and column buffer corresponding to jth column, first column becomes 1, so it becomes 1, and we have left column 1. So now there is 2, 0 here, the second element in the second row, and 0 means we will update. So the initial value of grid buffer is 0, so we will add 0 plus left tab, which is 1 now, plus column buffer. So column buffer was already 1 in the previous row, so we will add this 2, so 1 plus 1 becomes 2, and column buffer is not changed. So column buffer will be changed only when we get a corresponding E. Now we get W means we will reset column buffer and left both to 0. So now left tab becomes 0, and column buffer for the third column becomes 0, which was already 0, but now we have to keep it 0, so it becomes 0. And W, nothing is updated, so column buffer for W is still 0. When we go 4, so this is enemy, nothing is updated, so grid buffer remains the same, but at this point the left tab is increased to 1 and column buffer is also increased by 1. So now column buffer becomes 1 addition 1 for the fourth column, so it becomes, so column buffer initially was 0 1 0 0 after the first iteration. In the second we add 1 to this one and it becomes 1 1 0 1, so it's 1 is added. And now we will go to the third row, and now the left tab will be reset. However, we will remember the value of column buffer. So column buffer from the second row is 1101, and this will be used for updating values in the third row. So we copy, this is the grid buffer, we copy the first two rows as it is, so 0011 0200. Now it's time to update the third row. So let's go and see. The third row, first element is 0, so we have to update. Initial value is 0, so we will add the left tab, but left tab is already 0 here, so we just have the column buffer at this point. So column buffer here is 1, so this value becomes 1, and also column buffer stays the same. Next we have the E, and now the column buffer for this place becomes increased by 1, so it was 1 plus 1 becomes 2, and again we will not update it because enemy doesn't lead to update of grid buffer. Then we have 0, and this is good news. Now we will add things. So 0 means this enemy has caused the left tab to become 1, and now for here we are adding left tab, so 1 plus initial value of grid buffer, which is 0, and plus column buffer, the third column, which is 0, so it becomes 0 plus 1 plus 0, which is 1, and column buffer will stay the same, so it's 0 because it was 0. And for the last element, which is 0, we will not add anything to column buffer, so column buffer will be copied as it is, but the column buffer present value is 1, and we have the grid buffer value was 0, so 0 plus number of tab is 1, left tab is 1, so left tab 1 plus column buffer, which was 1 from previous iteration, so it becomes 1 plus 1, which is 2, because there was no value here initially, it was 0. So left tab and column buffer both are 1 for this element, and it becomes 2. So after iterating through the stage 1, all the 3 rows, we have this value of grid buffer 0 0 1 1 0 2 0 0 1 0 1 2, and we copy the same here 0 0 1 1 0 2 0 0 1 0 1 0. I would like to ask you to pause the video, go back and try to understand how we got this grid buffer through the stage 1, when we go from row 1 to row, and then row 2, and then row 3, and in each row we go from left to right and we try to update values. So basically we update the grid buffer by adding the left tab and column buffer. At that point, if the corresponding grid value was 0, and if it is enemy, we increase the column buffer and we increase the left tab, and when we get a wall, we make the left tab and column buffer both equals to 0. And another important point to know is, whenever we move from one row to another row, the left tab is initialized to 0. However, the column buffer remembers its past values, it remains the same, because this is very important for it to function well. So in stage 2, as I have already told, we go in reverse order. So we first handle the last row, then the first row, second row, and then the first row. Here we are using indexes 2 1 0 for showing the last, second last, and the first row. and then we have a column from right to left, which are represented by z is equal to 3 2 1 0. So now we start from this value, the bottom right, and we go in this direction, right to left, and then right to left, and then right to left, and we end up at the top left. So just reverse direction of the stage 1. Here again we define the column buffer 0 0 0 0, and it has memory. It will be same for, it will preserve its value from previous iterations and will be updated in each iteration for corresponding j index. So here again, while iterating the reverse order, if we found that there is 0 in the corresponding grid, so we will all again see the grid to make updates to grid buffer. So this is always grid, the original grid values are always taken as anchors for making decisions for updating grid buffer. So if we found 0, we increase the grid buffer value by adding the right tab and column buffer. Right tab is having a very similar meaning than the left tab, but since we are going from right to left, we use a different variable name, right tab. Okay, so if it is 0, we add both of them like we were doing earlier, and now the answer, which is the maximum number of enemies killed, is given by the maximum of previous answer and the current grid value. This is saying that basically answer is the maximum of all the values in grid, but in this way we don't have to store all the values of the grid buffer. So if grid I comma j is equals to e, so if we found an enemy, we increase the right tab by 1. This is very similarly what we were doing earlier. So right tab is increased by 1 and column buffer corresponding to that column is increased by 1 whenever we found that corresponding grid value is e, that is enemy. And here again, whenever we found that grid value ij is wall, we reset the right tab to be 0 and column buffer to be 0. So let's go and talk about the different iterations in the stage 2. So in stage 2, as I said, I will not, this straight line, black line shows that I'm not doing anything to first 2 rows. These are just complete or stays the same. We will just update the values in the third row. Okay, so we need, I have written grid here again just for easy and quick reference. So we see this value first, it is 0, so we will update the value of grid at this point. But right now the column buffer is all 0 and the right tab is 0, so it is 2 plus 0 means 2, didn't change. Next we see that we have again 0, and now again we will add right tab and column buffer to this value, and both of the right tab and column buffer are right now 0, so there is 0 plus 0 plus 1, which is 1. And then we found there is enemy e, so enemy, there is no change in the grid buffer, so we will just copy 0 from here to here. But after getting an enemy, now the right tab is 1 and column corresponding to this one becomes 1, so here also column buffer becomes 1 and right tab is 1 already. So when we move later, we found this element is we found that this element is 0, so we add the right tab and column buffer to the current value. So right tab is 1 and the current value is 1, so 1 plus 1 is equal to 2 because the column buffer was 0, so it becomes 2 0 1 2. This is our final third row, and we just keep copy it to the second iteration 2 0 1 2. Copy it. Now in the second iteration we will update second row, and we will start with the column buffer value here. So we have the enemy again when we are starting from right to left, so right enemy is there, so right tab becomes 1 and column value here is increased by 1, so now you will see the column value is 1 here. Next we have wall, so right tab is again becomes 0 and column value here, column buffer becomes 0, so it's again 0. Next we got O, it means we will update the value, so updating value means we will add the past buffer, so past buffer is 1 and to the current value which is 2, so it becomes 2 current value plus column buffer 1 is 3 plus right tab is 0, so it becomes 2 plus 1, that is 3, And next we have enemy. So this enemy will increase the value of column buffer at the first point to 1, so it becomes 1. Right tab increased again to 1, but this of no use because now we will go into I is equal to 0, the first row, and right tab is again 0. So at this point we will have the column buffer which is 1101. So the first value is 0, it means we will update, so we will add the column buffer which is 1 to the current value which is 1, so it becomes 1 plus 1, that is 2. So here you see 2. Now again we have 0, so we will add something to the current value which is 1, and we will add the column buffer which is 0. So 1 plus 0 is 1 plus 0 is 1, which I wrote here, and the column buffer will be same 0 on here. Next is enemy E. So, and because of enemy, the column buffer will increase by 1. So 1 plus 1 is 2, so it becomes 2 here, and the right tab is also 1 here. And then next we have 0. So 0, we will add right tab, column buffer, and current value. So current value was 0, we add the right tab which is 1, becomes 1, and when we add the column buffer position 1, it becomes 2. So the final grid buffer is 2012 0300 2012, and clearly 3 is the maximum value, which is the answer for this problem. Here I see that we are already taking the max of answer and grid buffer I comma j for all I and j in the second stage. Answer variable is already encapsulating the maximum value, which is 3. So this is what I wanted to explain through this video. Now we just code whatever we did. So we have a max skill enemies, self comma grid. So grid is basically a list, 2D list or grid of strings, and n is the number of rows, so it's the length of grid, and if number of rows is 0, we return 0, and m is the number of columns, this is length of grid O, and if m is equal to 0, the return 0. So column buffer is 0 into number of columns, okay, and grid buffer is the same size as the given grid, so that is why it is the zeros of size number of columns repeated for all the rows, because n is the number of rows, and answer is the maximum number of enemy skill, so we initialize it to 0, and I is the row parameter which we initialize to 0. Now the main code is on this page. We iterate while I is less than n. We initialize this equal to 0, left tab is 0. As I said, for each row we have to initialize left tab to be 0, and while the column is less than em, which is the number of columns, because the index is from 0 to m minus 1, we check for grid values. So if grid value is 0, we add, well, here equality should be plus equal to, so grid buffer is equals to grid buffer plus left tab plus column buffer. So column buffer and left tab are added whenever we have grid is equals to 0. When grid values are enemies, we try to put left tab is equals to 1. This is wrong, actually it shouldn't be 0, so left tab should be 1, and column buffer should be increased by 1 whenever we have enemy, and when both of these conditions are not there, it means there is wall, we make left tab is equals to 1 or 0, and column buffer to 0. So column buffer and left tab both become 0 when we have wall, when we have different conditions than these two, and when we have 0, we plus minus plus is equals to, so we increase the grid buffer by left tab and column buffer. Here it should be plus equals to, I will repeat, and here it should be plus equals to 1 plus equals to 1. And then we will keep increasing first the j, which is column variable, and then the row variables, and after we are done, the first stage is performed by this code, the above code. And now from this point, column buffer, again we start doing the second stage. So we initialize the column buffer to all zeros, 0 0 0 0, and we start from I is equals to n minus 1. So we are going from the highest row to upper, from bottom to up, and while I is a positive number, and we also go from right to left, so we start from m minus 1. Right tab is very similar to left tab and slice to 0. So while z is greater than or equal to 0, we look at the grid values, and whenever the grid buffer it is 0, the grid buffer is increased, so it is right. Same expression should be here, plus equals to should be here, because the same logic, plus equals to right tab plus column buffer corresponding, and then the answer is given by the maximum of answer and grid, this current grid value. Otherwise, if there is an enemy, we increase the right tab by 1 and column buffer by 1, and this logic is correct, and same logic should be here. Okay, and I'm sorry for the typo. And now if we get a wall, we reset the right tab and column buffer to 0, and we keep decreasing the column variable and then the row variable, and we keep doing it, and then we return answer, because answer is somehow tracking the maximum of all the values in the grid buffer. I already explained you this numerical example and went through it. I strongly suggest to run through this example manually to understand the dynamics of the problem, and you can pause this video to understand that. So I thought, since this is a little rigorous problem and could lead to some confusion, I have included the official bomb enemy problem description, so which is like here. You can always find the link to the problem in the description of this video. However, I also include here just in case you want to read it right here. And this is the code, the exact same code which I wrote above, with the typos are removed. So basically we keep adding. So left tab is increased by 1, which is important. Here it should be plus equals to 1. Even if it is not, it's fine, because initially it's 0. But this is good to do the plus equals to, I believe. And that's it. So I think you can pause the video and take the code. And I tried to use the variables names which are meaningful, so that you can relate to it with the example I discussed. Please like my video and leave your comments or any problems if you want me to cover that in the next video. Thank you, and take care until we meet again. Thank you so much.